Okay, so 3.2 talks about the derivative as a function. All right, so what do we know so far? We just talked about the average rate of change versus the instantaneous rate of change. And what's going to be new in this section is talking about the formal definition of a derivative. Okay, for those of you who have seen calculus before, we may know that there are a bunch of shortcuts to this formal definition. But if I specifically ask for the formal definition, I'm referring to what we're going to cover right here. Okay. So what is this formal definition? Let's take a look. So we can find the slope of a secant line, or average rate of change, using this formula, f of b minus f of a over b minus a. Right? That's what we just talked about. By picking 2 points, and these are the 2 points we chose earlier that are really close together, we can approximate the slope of that tangent line, or instantaneous rate of change, using this formula, right? Here's all a derivative is, okay? So because we use this idea so much, we gave it a name, all right? Just like your parents knew you were going to hang around for a while, so they gave you a name. And here you are, whatever your name is, okay? So because we knew this idea was going to stick, we're like, this is so important, we should give it a name. And that name is called a derivative. And so no matter how complicated the computations get that we're looking at, if I ask for slope, in your brain, I want you to think, oh, she's asking about derivatives. All right, so as soon as you see that word derivative, you're thinking slope. All right, so derivative, slope, derivative, maybe more specifically, instantaneous rate of change. Okay, those all mean the same thing. No, that was to the general public, not to me. All right, so the derivative of f of x with respect to x is the function f prime, okay? So this little symbol, the way we read this is f prime of x, okay? We're gonna get into a lot of notation, so it's important that we learn how to read it, okay? I think I've come to realize that notation is some of the hardest stuff to figure out in math, because we might understand the concept, but as soon as someone uses a symbol instead of the words, maybe we forget that. Okay, so this is going to be especially important in our calculus class. So a derivative, or slope, or instantaneous rate of change, we call it f prime of x, and is defined by that instantaneous rate of change formula. Okay. So that instantaneous rate of change idea is exactly what we mean when we say find the derivative. We're finding the slope at a specific point, not between 2 points, but like at 1 point. So how are we going to be using it? All right. Let's start with example 1. So we've got a function, f of x equals x squared, our good friend. We know it's a parabola. We know that it's facing up. And let's use the derivative, or find the derivative, using the formal definition of the derivative. Okay, we're going to learn a lot of other ways to find the derivative, but right here, right now, I want us to use the formal definition. Okay, so all we're going to do is we're going to take the formula that we have here, we're going to rewrite it, and then we're going to plug in what we know. Okay, so f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So all I've done is just copy the formula from above. And now I'm going to plug in the function that I have, okay? There's nothing to substitute for h, so I'm just going to keep that in the denominator, okay? What can I substitute for f of x? X squared, perfect. Now I'm gonna put parentheses around here because it doesn't matter for this question, but it's going to matter for future questions. And I don't want us to get into a situation where we're not used to putting those parentheses there, okay? So f of x we know is x squared because they told us f of x was x squared. Whoops. What can we put in for f of x plus h? Okay, this is probably where I see most of the mistakes. Let's write these ideas down to the side. F of x plus h could be equal to x squared plus f of h could be equal to x plus h squared. Any other ideas of possible ones? I've seen people say this, well, if x is x squared, then it's going to be x squared plus h squared. I mean, why not? Okay, but we have a couple options here. Okay, maybe another one is x squared plus h. Okay. Okay, so let's think for a moment what this notation is asking us, all right? I'm asking you to take x plus h and plug it in everywhere you see x. So instead of saying I plug in x and I get x squared, without even thinking about how you're going to simplify it, I want us to plug in x plus h everywhere there's an x. What does that give us then? Any of these options? If all we do is plug x plus h, so sub x plus h in for x. Do any of these answer choices, let's go A, B, C, D. What do we think? Type your guess into the chat and let's see what we get. Oh, 2 brave souls have gone so far. All right, all right. I see a lot of votes for B. Okay. So I think it's important to talk about why we make that decision, okay? So if the definition of like a function notation is that everywhere you see an x, you substitute it with whatever you want, okay? Then B makes the most sense because I want to put x plus h everywhere I saw the x, right? That follows the structure most similarly. But let's say someone said part C, what is wrong with answer choice C? Like, why is x squared plus h squared wrong? Okay, so maybe that person didn't FOIL properly or they didn't multiply it out properly, right? I think that's a one good guess. What else might this person have done mistakenly? Yeah, I've talked to some students who put like x squared plus h squared and they're like, I don't know, it just, this function says to square everything, so I just squared each part. Right? Like there's an X that you put in, there's an H that you put in. It's almost like they plugged them in separately and then they squared it, right? Now, that's not what the notation is asking. The notation is asking us to just substitute in X plus H everywhere you see the X, okay? What's the mistake that happened in answer choice D? Mm-hmm. It's almost like we ignored what the notation was and we're like, well, let's just keep the function and just stick an H on the end. I don't know what to do with it, like panic mode, right? And we don't want to panic. We don't want to cry either. Okay. I mean, you can cry, just don't get it on your paper. It's going to be real hard for me to read. I'm just kidding. That's cold. Okay. So we don't want to just like put the H on the end either, right? Now, this last one, answer choice A, I would say is similarly incorrect because we're treating the X and the H separately. Okay. And the thing here is we got to treat X plus H as a unit, like it goes together inside whatever the function is. Okay. And so for that reason, for the f of x plus h, we're going to put x plus h squared. Now, for some of us, this concept is pretty straightforward, and you're probably like, why is she belaboring this point? Like, I get it, I get it. But what we really want to make sure we understand here is that the structure here is going to be the same even when we get to more complicated questions, okay? All right. So if I try and substitute in 0 for h, I'm going to get x squared minus x squared over 0, which is problematic. And so we're going to have to go back and think about ways that we can make this better. And turns out that way, in this case, is we're just going to expand. We're going to take that numerator and we're going to unpack it a little bit. So x plus h squared is going to give you x squared plus 2xh plus h squared minus the x squared that was there before. So I've just multiplied that out, the first part, and I've kept the second part the way it is. Now, if I want to get rid of the parentheses, the first set, I'm all good. The second set, I just have to distribute that minus sign to the x squared. Okay. What if there were more things inside the parentheses of the orange one? How would I handle that minus sign? I would have to distribute that minus sign. Okay, so just kind of think about that as you're going along, that if there's more than one term inside that second parentheses, you'll have to distribute, okay? But check out what's happening here. I got an x squared and I got a minus x squared. Those go away. Now, what do I have left in the numerator? I have 2xh plus h squared. This is a really good indicator that you've done your job well. And here's the indicator. Your numerator has an h in all the terms, so you can factor out that h. And the inside becomes 2x plus h. Okay. Why would it be so crucial to be able to factor an h out? Perfect. This h in the numerator reduces with the h in the denominator. And that h in the denominator, that was the problem, right? When we plugged in 0, we had a 0 on the bottom. And so in order to address that, we expanded a little bit. And let's see what we get now. The limit as h approaches 0 of 2x plus h. What happens now when we plug in 0? What do we get? We get 2x. Okay. Okay. Now, David, I'm glad that you said that. This should seem familiar. Okay. If you've taken pre-calculus or we did it in our class as well, sometimes this is referred to as the difference quotient. Okay. Now, technically, the difference quotient talks about without the limit as h approaches 0. It's just like all the other stuff, like the purple and orange stuff. Okay. But what we have here is that the derivative of x squared is 2x. Okay. Let me say that one more time. The derivative of x squared is 2x. What's another word for derivative again? Derivative is, I would say, slope. It's not a limit, it's a slope. Okay. So what I'm really saying is, yep, or instantaneous rate of change. So what I'm saying is that the slope of x squared is 2x. Okay. The slope of x squared is 2x. Yeah, nope, that's a really good question. So let me squeeze it in over here. If f of x equals x squared, right? F of x plus h is just replacing everywhere I saw the x with an x plus h. So replacing it with x plus h and squaring it. Okay. Yeah, sorry, it was a very long and drawn out way of getting there. But basically, whatever the structure is, we're plugging in x plus h in there. Okay. I actually think this is a good place to pause for today. Okay. I know that, like I said, this is not on the exam on Friday. So let's kind of